Hello friends, my name is Yusuf and I'm going to present on Kolmogorov-Arnold Network and its application in large language model. Okay, here you see the list of the outline. We start with definition, comparison, compositional structure learning, univariate function optimization, how do they work, and continue with combination, training can, catastrophic forgetting, how can could revolutionize large language model and reference. Here you see a structure of the Kolmogorov-Arnold network. You see that in comparison to multi-layer perceptron, we have a learnable activation function on each edge. Definition, as you can see also here in CAN, each edge contains a learnable activation function, which is a univariate function parameterized as a spline. But what is a spline? Spline are piecewise polynomial function that can closely approximate complex univariate function. Okay, you can here read about the intuition. But what is the main advantage of the spline in comparison to the global activation function such as sigmoid and reload? The main advantage is local adaptability. It means that when we adjust a univariate function, it only affects on its neighborhood. The change are not global. The change just affect on the neighborhood when we change and adjust the univariate function. This is the main and biggest advantage of the spline. Okay, we have two main theorem. Universal approximation theorem. It means that with the right setup, a neural network can learn to represent any kind of the relationship between input and output. And now, what is Kolmogorov-Arnold representation theorem? Uh, it says that when we deal with a complicated equation or machine learning task, we should break this task into multiple small tasks. That is the main idea of this theorem. Okay, comparison. As you can see here, mm, CAN, a Kolmogorov-Arnold network that we abbreviate as a CAN, has some non-linear and learnable activation function on each edge, while in multi-layer perceptron we have a non-linear fixed activation function. We also have some weight for each edge in the multi-layer perceptron. These weights are replaced by non-linear and learnable activation function. We sum the output of this activation function and pass to the another one. As you can see here, we sum them together, pass to the another univariate function, and here we sum them together, pass this one, and sum together, pass to this activation function. This is the idea of this formula. We sum together the activation function and pass to the next one. This is the main idea of the CAN network, and you see the formula for multi-layer perceptron. We multiply weight with input, add bias, and pass to the non-linear activation function. As you can see here also, we have a learnable activation function on edge with some operation. We do some operation on nodes. Okay. While in multi-layer perceptron, we have fixed activation function on node and learnable weights on edge. Okay. Compositional structure learning. What is compositional structure learning? Can like MLP can learn the compositional structure of a problem. But what is a compositional structure? Compositional structure means that can identify and learn the relationship between different features and understand how these features contribute to the output. Okay, this is the feature that is shared between CAN and multi-layer perceptron. Univariate function optimization. What set CAN apart from MLP is their ability to optimize univariate function to a higher degree of accuracy. I think this is clear. During training, can optimize the spline to best fit the target function. Okay, how do they work? At its core, it can learn both compositional structure and the univariate function of the given problem. This allows Can to not only learn feature like MLP, but also to optimize these learned feature to great accuracy. Okay, now have a look from another perspective. As I have written here, can leverage the strength of both spline and multi-layer perceptron while avoiding their weakness. Okay, what is the advantage of spline? Spline are highly accurate for low dimensional function or univariate function. Meanwhile, multi-layer perceptron are good to learn compositional structure. Okay, and what is the disadvantage of the spline? They have the problem of curse of this dimensionality. When the size of input go high, it become problematic. And what is the disadvantage of the multi-layer perceptron? It cannot optimize univariate function. In Can we take good of this approach? Can overcome this limitation by combining the compositional structure learning of MLP, as you can see here, with the univariate function optimization of the spline. Okay, as you can see here, this is the idea of the Can. For training Can, we use backpropagation algorithm, same as multi-layer perceptron, and there is no difference here. A catastrophic forgetting. What is catastrophic forgetting? Catastrophic forgetting occurs when a trained neural network, uh, let me tell in simple language, when we want to fine tune a neural network with new data, uh, it this network forget its previous weight, previous learned data. This problem is called as catastrophic forgetting. Can are less prone to catastrophic forgetting due to B-spline local control. As I discussed in the first of this video, the main advantage of the spline is local adaptability and change uh, only manifested to the neighborhood, and their effect is not global. That's why can are less prone to catastrophic forgetting. In multi-layer perceptron, weight change globally, causing the network to forget all data when learning new data. Okay, I think this is clear. In Can, due to local adaptability, we don't have this problem. How can could revolutionize large language model? There is a possibility to create more compact and efficient model without sacrificing performance. By emerging the Can, we can hope to have more compact and efficient model that can help us to outperform the exact architecture for training large language model. Another issue is that researcher could gain more insight into how the model process and generate language. How this happen uh, can help us to have a transparent and explainable neural network, and this can contribute to developing large language models and interpreting their behavior. Can ability to learn both compositional structure and univariate function can help a large language model to learn from fewer examples. This is a very great impact that can have on the large language model. Here you can see my reference. Okay, if you learn something from this video, I appreciate to like and subscribe. Thank you very much.